Have you ever wondered how to reduce variance in your regression models? Perhaps you've struggled with overfitting, where your model performs exceptionally well on training data, but falters when it comes to unseen data. If so, you've stumbled upon the right place. Today, we'll dive into the world of ridge and lasso regression, two powerful techniques that help in tackling these challenges. Imagine you're building a regression model. You've gathered your data, built your model, and you're ready to make predictions. But something's not quite right. Your model, while performing admirably on the training data, fails to generalize well to unseen data. This is a classic symptom of a model with high variance, or in simpler terms, a model that's overfitting. Enter the concept of regularization, our knight in shining armor against overfitting. Regularization introduces a small amount of bias into our model, but in return, it significantly reduces variance. It's a trade-off, but one that results in better long-term predictions. Now, let's meet our first hero, ridge regression, also known as L2 regularization. Ridge regression works by adding a penalty equivalent to the square of the magnitude of coefficients. This penalty term discourages large coefficients, a common symptom of overfitting, and keeps them in check. However, ridge regression doesn't completely eliminate coefficients, it only minimizes them. This brings us to our second hero, lasso regression, also known as L1 regularization. Lasso regression operates similarly to ridge regression, but with a twist. Instead of squaring the magnitude of coefficients, lasso takes the absolute value. This subtle change has a significant impact. Lasso has the ability to exclude useless variables from your equation by reducing their coefficients to zero. This makes it a great tool for feature selection when dealing with a large number of irrelevant variables. So you might be wondering, when should you use ridge and when should you use lasso? Well, the answer depends on your specific needs. Ridge regression is a good choice when you believe all the input features influence the output, but you'd like to minimize their effect. On the other hand, lasso regression is your go-to option when you suspect that only a subset of your features significantly influence the output. To sum up, ridge and lasso regression are two powerful techniques in the fight against overfitting. They introduce a small amount of bias to combat high variance, but each does so in its own unique way. Ridge regression minimizes the effect of less important features, while lasso regression can completely eliminate them. So next time you find yourself battling high variance, remember ridge and lasso, your trusty allies in the war against overfitting.